Hello, I'm gonna go over Project 31 real quick. Some things I'm going to kind of speed through, and then other things I'm going to take my time to show you all how to do it. Okay, first of all, you are supposed to go onto the syllabus and then go to I don't know how to pronounce that. I think it's photoplankton data graph. You're supposed to copy that. All I did was just press save, and then I was able to save it into my own Desmos account. And then I put my name here, and then I already had the graph. Now, that took care of numbers 1 and 2. Now I'm going to press enter, so this will continue on to go to number 3. It says create a rational regression model composed of a linear function divided by a quadratic function. Okay, so this is what we would need to do. Quadratic function and linear function both start off with y equals. So what we would do, we'll put y1, then we'll do the tilde. And then for our numerator, we would put the m, and then let me do the division sign here, and then go back up to the top. It'll be mx1, and then plus b. Now we go to the denominator. Now remember, with the quadratic function is ax squared plus bx plus c. So we'll do ax and then 1. Then we'll take this squared plus bx1 plus c. Okay, now we have our values here. So we have our graph. Now we want to put these values in. So we would do y is equal to, now the m here is, we're going to round to 4 decimal places. It'll be 0.4814. And then we're going to do a division. I like to get that out the way. And then we'll put x. And then b is a negative, so we'll put minus 1.0112. So that took care of the linear function. Now the quadratic function. Now a here is 0.0, what's that, 870, and then x squared plus, well, actually it should be minus, b is 1.0112 x, and then plus c, which would be 3.56, what's that, 21. Okay, now we put in our graph here. We don't need this blue part anymore, so let's take that off. Okay, now we need to restrict this graph because we're not going this far over here. We want it to look like the graph that's listed. It tells us, let me go here to the syllabus. It tells us here at 31, it says, note your solutions graph should look similar to, and it says this. So we click here. And it shows us this graph here. All right, so let me move this back. All right, so we need to put a restriction here. Now, we know that the lowest value goes to about 5. It's less than or equal to x, which is less than or equal to 14. Now, it looks very similar to what we had here. All right, so now let's go back. I need to move this back over out the way. All right, now that was number 3. It says identify and graph the horizontal asymptote. Use the gear symbol to change the style of the asymptote to dotted. Now we know the horizontal asymptote is when y is equal to 0. So what we would do is we'll put y equals 0. And then we want to change this so it'll reflect a different type of graph here. We'll click and hold down here. Oh, it's not letting me do it. Oh, here we go. And we could click the dotted line. So we know it'll never touch this x-axis, this graph. It'll never touch the x-axis. It may get close, but it would never touch it. Okay, so then now, let me see. Says number 5, use a note text box to answer the question. What appears to happen to the verse as the number? Now you can answer that yourself. It says use the r squared value. Okay, we had an r squared value here. It says use the r squared value, not r, to discuss how well the model fits the data set. Now we know with r and r squared, the closer it gets to +1 or -1 means that it's a very good graph. Now this right here is almost at the halfway point, so it really doesn't fit the data that well. And you will have to discuss that in your conclusion. And that's basically it for Project 31. If you have any other questions, please let me know.